All right, let's jump right in. Forget what you think you know about nuclear research from old textbooks. Today, we're stepping into a super high-stakes, modern world of innovation. This is a truly global mission, a race to solve some of the planet's biggest energy and environmental puzzles. So, where on Earth do we even begin?
Well, it starts with a question that sounds like it's straight out of a disaster movie. Seriously, how do you clean up the most dangerous places on the entire planet? We're talking about legacy sites with absolutely lethal levels of radiation. How do you go about safely taking apart an old reactor or figure out how to contain waste that's going to be radioactive for thousands of years?
The answer, believe it or not, is pretty direct. And yeah, it sounds like science fiction, but it is happening right now. You build a whole new kind of workforce, one that can go into the places that we just can't.
And that brings us to our first section, robots versus radiation. And this isn't about some clunky brute force machine, no. This is a whole new frontier of precision engineering, where intelligent machines are literally our frontline defense.
And look, these aren't just cool ideas on a whiteboard. The UK's National Centre for Nuclear Robotics, which is actually a team-up of 8 different universities, is building these advanced AI and robotic systems as we speak. These machines are designed to go where no human possibly could, carefully taking apart old reactor parts and sorting hazardous waste with a kind of precision that just makes the entire process so much safer for everyone involved.
So, you might be wondering, who's the one coordinating all this incredible research? Because a single team, no matter how brilliant, can't solve these massive challenges alone. It takes a central hub, a real powerhouse where all these different threads of innovation can come together.
And that's where the Dalton Nuclear Institute at the University of Manchester comes in. They're about to hit their 20th anniversary in 2025, and that's not just a milestone. It marks 2 solid decades at the absolute forefront of UK nuclear research, with some of the most advanced academic facilities you can find anywhere.
The best way to think of the Dalton Institute is like the mission control for all of the UK's academic nuclear research. Their job isn't just to do their own studies, it's to connect the nation's brightest minds from universities, private companies, and the government, making sure everyone is pulling in the same direction on this huge challenge. And it's that power of connection where the real breakthroughs happen. Dalton's strength isn't just what's happening in its own labs, it's in its incredible ability to build and manage this whole network of specialists, bringing together all these different teams to crack different parts of the nuclear puzzle.
This table here gives you a fantastic snapshot of how it all fits together. So, the Dalton Institute leads the RAIN Hub. Those are the folks developing the very robots we were just talking about. They also spearhead nuclear materials research at the Henry Royce Institute, which is absolutely crucial for creating things like waste containers that can stay safe for millennia. And they host the Research Support Office for Nuclear Waste Services, which provides the hard science for the UK's long-term geological disposal plan. It's a perfect collaborative ecosystem.
But here's the thing, this isn't just a UK problem, not by a long shot. It is a global challenge, and that collaborative spirit stretches right across borders. You've got countries all over the world tackling it with their own unique and amazing innovations.
For example, over at Kyoto University in Japan, researchers are laser-focused on creating waste strategies that are tailor-made for Japan's unique geography. They're developing solutions for a country that's not only super densely populated, but is also one of the most earthquake-prone places on Earth. The work they're doing is absolutely vital for ensuring long-term safety there. And then you jump thousands of miles away to Sapayev University in Kazakhstan, and you see a completely different but equally brilliant approach. The teams there are developing these new low-cost materials that are partly made from biomass, so think organic matter. And these materials act like a super sponge, literally pulling radioactive contaminants right out of the water. It's just a fantastic example of using local resources to find really effective solutions.
So, okay, we've got robots, we've got advanced materials, global collaboration, but why does all of this matter so much? What's the bottom line? Well, it's because this research connects our past, our present, and our future.
This research does 3 incredibly critical things. First, it helps us clean up the legacy of the past, right? Safely decommissioning all those old facilities. Second, it secures our present by making the reactors we depend on today safer and better performing. And finally, it powers our future. It's laying the groundwork for next-generation tech like nuclear fusion, which, could be a source of almost limitless carbon-free energy. It really all leads to one final thought. In a world that is just so hungry for clean, reliable energy, the work happening in these labs, it isn't just academic, it's foundational. It kind of makes you wonder, doesn't it? As we look to the horizon, are these the scientists, the engineers, and yeah, even the robots who are quietly building our clean energy future?
Welcome to our Quickfire Science Challenge. Today, we are busting myths about nuclear energy and its leftovers. We have prepared 2 fast-paced questions to see if you are a nuclear expert or if you have been misled by popular movies and legends. Let's begin. True or false? All nuclear waste stays radioactive for millions of years. Answer: false. Explanation: while some isotopes last a very long time, the majority of nuclear waste consists of materials that decay to safe levels within a few decades or a few centuries. True or false? Most nuclear waste is actually recycled in some countries. Answer: true. Explanation: countries like France use advanced reprocessing to extract unused uranium and plutonium from spent fuel, which significantly reduces the total volume of waste and creates new energy.
How did you score on our nuclear waste quiz? Science is often more complex than it appears on the surface, and understanding these facts helps us make better decisions about our energy future. Make sure to follow for more lightning-fast science facts and urban legend debunking.
Knowledge is power. Please subscribe, like, and share to Think Tank 2.0. Thanks.